Alright guys, today we're going to talk about section 3.4, arithmetic sequences. And by the end of it, you should be able to identify and describe an arithmetic sequence. And a sequence is really just a list of numbers that form some sort of pattern. And each number in there is a term of that sequence. Now what makes an arithmetic sequence different than another type of sequence is that to get from one term to the next, or those consecutive terms, we are changing by what's called a common difference. So if you relate this back to what we just came from when we were dealing with linear functions, that common difference would be represented by the slope, that constant rate of change. And then today we're going to talk about two different ways in which we can express these arithmetic sequences. We have the recursive formula and the explicit. So the first one we want to look at is going to be the explicit formula. And so you see down below here, the explicit formula is defined as a sub n, so some term, whatever number that is n, is equal to a sub 1, that's the first term within that sequence, plus the term number minus 1 times the common difference. So if we were going to plug something in here, say I wanted to find the 43rd term, that would be a sub 43 is equal to whatever that number is. I don't know what it is because we're just making this up, but whatever the first term is, say it's 1, and then plus 43 minus 1 times the common difference, and that common difference could be anything, maybe it's 2. And so then we would just evaluate and we would have the 43rd term within that sequence. So what you need to know in this is going to be the first term, a sub 1, and you need to know the common difference. Those are the two things you need to know in order to find any term within that arithmetic sequence. So looking at the first examples, in this ordered list, what we want to identify is, just like when we were doing linear functions, we want that rate of change. Now it's called common difference when we're talking about arithmetic sequences. So I'm comparing one term to the next, and I want to know how do they change. And from 26 to 39, 39 to 52, to 65, to 78. So we see that common difference is 13. So we know that, yes, this is an arithmetic sequence. And how are these related to functions? Well, we have n, the term number of the sequence, and then you have essentially this input. So we take some arithmetic sequence to the n term. In this case, as you look up above, a sub 1 is equal to 26, a sub 2. So very similar to that evaluator function notation when we're substituting in. And then we have the formula you saw up above, that explicit formula. A sub 2 then is 39. A sub 3 is equal to 52. And then that pattern just continues. So as you see, or you will see as we progress here, that they're very similar to the concept of a linear function that we were just dealing with. How do you represent sequences using subscript notation? Well, pretty straightforward. We're just talking about a sub 1, and that's equal to the first term in that pattern above, that's 26. A sub 2, the second term of the sequence, was 39. A sub 3, the third term within that pattern, was 52, and then that just continues. Okay, so you just use that subscript notation. That's going to denote what term number we're talking about in the arithmetic sequence. So looking at the next example here, applying the recursive formula. So we want to determine the formula that expresses or represents the height off the ground of the nth number of step within that pyramid, whatever number of step that might be, whatever n might be, whether it's the 100th or the 62nd or the 43rd. We don't know, doesn't really matter. So we want to go ahead and define that formula. Okay, so the recursive formula is found actually right below here, and it's just a variation on the explicit formula. We'll talk about it here shortly, but it's just a sub n is equal to a sub n minus 1 plus 26. And what do these things all represent? Well, pretty straightforward. We've got that's the common difference. And then here, this quantity right here, this a sub n minus 1, what this is really asking for is the previous or prior term. Right? If I was finding a sub 2, I would plug in a sub 2 minus 1, so 2 minus 1 would be 1. That would be asking for a sub 1, so the term that preceded it. So in order to do this, you need to know the prior term, and then you just add on that common difference. So if we look at this example down below, using the recursive formula, and we see it there, where a sub 1 equals 26, we want to find the height of the third step. So we're going to go ahead and evaluate that. So I know that a sub 1 is 26, and I know that a sub 2 would be equal then to my formula, a sub 2 minus 1 plus 26. And what is a sub 2 minus 1? Well, that's equal to a sub 1 plus 26. And what was a sub 1? Well, it was 26, so we just sub that in. So 26 plus 26 equals, it looks like 58. Okay? So when I want to go ahead and then find the third, I just say a sub 3 is equal to a sub 3 minus 1 plus 26. And a sub 3 minus 1 is a sub 2 plus 26, and a sub 2 I just found, that was 58 plus 26. And 58 plus 26 will be 78 centimeters. So you can see the downside to the recursive formula is that it requires me to find or to know the term that preceded it. So in order to find the next term, I need to know the one that came before. Now in number 5 here, write a recursive formula to represent the total height of the nth stair above the ground if the height of each stair, so that's my common difference, is 18. And since we're talking about stairs starting at ground level, your first term, if you write in the explicit formula, is probably also 18. But in this case, we're asked to find the recursive formula. So that formula is a sub n is equal to a sub n minus 1 plus your common difference. In this case, my common difference was 18. So that would be the recursive formula expressing this arithmetic sequence. All right, let's look at the next example. So we want to apply the explicit formula. So first then, let's go ahead and make sure that we recall the explicit formula. The explicit formula is a sub n equals a sub 1 plus n minus 1 times d. So there's my formula. So the first thing we want to do is we want to make sure that we have a constant rate of change. So from 1 to 2 to 3 to 4, just like we were doing with the linear function and the slope. And then we want to compare this change in output and make sure that this is constant. So I have 26 to 38 to 50 and to 12. So it looks like I have a constant change of 12. So if I have my formula there, and I know that, so what do I know? Well, I know that my first term is equal to 26. I see it right here, first term. And I know that my difference or common difference is equal to 12. Okay? So if I want to find the formula to represent this, all I need to do right now is a sub n is equal to my first term plus n minus 1 times d. So that is the explicit formula that models this. So in this example, part B, the cost of renting a bicycle for 10 days, we know, again, let's write our formula. A sub n is equal to the first term plus n minus 1 times d. And what do I know? Well, I know that a sub 1 was equal to 26. I know that d was equal to 12, and I know that n, the term number I want, is right there, 10. So now we just substitute. So a sub 10, because I'm evaluating for the 10th term within that sequence, is equal to the first term plus the term number less 1 times the common difference. Okay, so then we'll go ahead and evaluate this. So a sub 10 is equal to 26 plus, that's 9 times 12. So I have 26 plus 9 times 12. 9 times 10 is going to be 90 plus 9 times 2, which is 18. So that's going to be 108. And then I add 26 to that. So that's going to be 134. So a sub 10 is equal to 134. Okay. How is the explicit formula of an arithmetic sequence related to a linear function? Well, take a look at how similar they are in terms of the output. So we've already talked about that common difference. Let me scroll up a little bit here. And if you think about the equation for this, we had that a sub n is equal to a sub 1. My first term was 26 plus n minus 1 times the difference of 12. So what if we simplified this a little bit? So if we took this, we distributed it through. So I had 26 plus 12n minus 12, 12n minus 12. I combined 26 and negative 12 because those are like terms. So I get a sub n is equal to, I'm going to say 12n, and then 26 and 12 is going to be a positive 14. And then if I bring that up over here, a sub n equals 12n plus 14. And then I change this from a sub n to something like y equals. We see that we have a linear function in slope-intercept form that represents or would model that change from each nth term within the sequence. And again, we've talked about this a few times now, that common difference is the same as the slope in a linear function. Okay? And looking at number 7, give this one a try. We'll scroll up here a little bit. Cost to rent a bike is $28 for the first day. So there is your a sub 1. Plus $2 for each day after. That is your common difference. Write an explicit formula for the rental cost of n days. So let's take a look. So I have a sub n is equal to a sub 1 plus n minus 1 times d. I know that in this case, a sub 1 is equal to 28. D is equal to 2. So we'll just sub in. So a sub n is equal to 28 plus n minus 1 times 2. And then it asks us to find the cost, or so to evaluate it for 8 days, which would be the 8th term. So if I substitute that in, I have a sub 8 is equal to my first term, 28, plus 8 minus 1 times 2. So again, a little simplifying, 8 less 1, 7. 7 times 2 is 14. 14 and 28 is going to be 30, 42. So $42 for 8 days. Okay, another way to notate that using your subscript notation, a sub 8 is equal to 42. Okay, let's take a look at the recursive model. Okay, so in this particular example, we're given the recursive formula for the height above the ground of the nth step of the stairs shown. Okay, So we see that modeled here. A sub n is equal to a sub n less 1, so the prior term plus 4. So I know that right here, this is my common difference. Okay? And then I'm told that a sub 1 is equal to 7, so there's my a sub 1. And we're asked to find the explicit formula that finds the height. So we're taking this out of the recursive formula and then rewriting it as explicit. So again, I just need to remember or check my notes. My explicit formula is equal to my first term plus n minus 1 times d. So now we'll go ahead and substitute, and then we can simplify a little bit. So a sub n is equal to my first term, that was 7, plus the term number times d, and in this case d was the 4 for each step. And then we can go ahead and essentially distribute that back through. So I get 7 plus 4n minus 4. I do some combining of like terms here. The 7 and the minus 4 can go together, and a sub n is equal to a sub n is equal to 4n plus 3. So that's an explicit formula that's written. It looks just like a linear function. Y equals, or f of x here, equals 4n plus 3. There's my y-intercept, easily graphed. There's my slope, my constant rate of change, common difference, okay, 4. And then we can model that however we'd like. So let's try number 9, similar setup. So we're going to take the same thing, and we're going to rewrite it as an explicit formula. So again, formula, identify your knowns. My first term's 10. The d from the recursive formula is right here. Okay, so that's going to be minus 3. So then we'll go ahead and sub in. So a sub n is equal to first term plus n minus 1 times d. Distribute. Combine like terms. And I've got negative 3n plus 13. Okay, let's do the same thing down here. We'll try another. So again, my formula, a sub n is equal to a sub 1 plus n minus 1 times d. A sub 1 is equal to negative 1. I'm told my difference is 2.4. So we'll sub in. We'll distribute. Then we'll combine the like terms. So I have a sub n is equal to 2.4 times n, and I have negative 1 minus 2.4 more, minus 3.4. Okay? Okay, so let's talk about going the other way. So let's talk about writing a recursive formula from the explicit. Let's scroll up here. Okay. So I want the recursive formula from the explicit. So I'm given the explicit formula here. Again, should recognize that this value, just like slope in a linear function, this is your difference. So my recursive formula is a sub n equals a sub n minus 1 plus the difference. So that's your formula. So now we've got to identify, what do I know? So for this formula, I need the difference. And we also want to find the first term, because that's going to help us find successive terms, or terms that come after. So I already know that the difference is 1/2. If I want to find a sub 1, well, all I have to do, I'm given the explicit formula, so I can just evaluate that real quick. A sub 1 is equal to 1 plus 1/2 times the term number, first term, 1. So what's 1 plus half times 1 is 1/2. So that's just 1.5, or 3/2. Okay, so all I really need then to write the recursive formula, this is why we like it, because it's really easy to write. It's just not always as easy to evaluate. So it's a sub n is equal to a sub n less 1 plus the difference, and the difference is 1/2. And then I can identify that a sub 1 is also equal to 3/2, and that helps me evaluate or find terms that come after. Okay, so take a look at the last two examples. So again, a sub n equals 8 plus 3n, so that is my explicit formula. So let's find the recursive. So the recursive formula again, let's write it out, is a sub n not a sub 2, a sub n. And that's equal to a sub n minus 1 plus the difference. So difference is easy to find. It's that coefficient of the variable, that slope. So there's d, and if I want to find a sub 1, I just evaluate. And that's equal to 11. So if I want to write the recursive formula of this arithmetic sequence, I just have a sub n is equal to a sub n minus 1 plus the difference, and the first term is 11. And then for the next one, so we'll go ahead and find the difference. Difference in this case is minus 5, so pay attention to the sign. So that's your difference, and my a sub 1 is equal to 12 minus 5 times 1, 7. So then we'll write our recursive formula. A sub n is equal to a sub n minus 1 minus 5, and the first term is 7. So again, a couple things to remember. Arithmetic sequence is just a series, a pattern of numbers with a constant or common difference. Okay, it's that sense of slope, constant rate of change. It's changing by the same amount every single time. So something is being added or subtracted to it every time. N is just representing the nth term, so some term number. And then we have two formulas. We have the explicit, which will find us any term within that pattern of numbers, the arithmetic sequence. And then we have recursive, and recursive requires that we know the prior term or a prior term in order to find the next term. Any questions? Bring them to class and we'll discuss.